Comparing exponential and quadratic functions can be tricky. First, you can tell that an equation is quadratic if its highest exponent is 2. P of x equals 6x squared is a quadratic function. You can tell that an equation is exponential if it has a variable in an exponent. Therefore, q of x equals 3 to the x is an exponential function. When looking at the graphs of functions, a quadratic function is usually a U-shape. Here's the graph of p of x as an example. But be careful, because if you zoom into just one side or the other, you might not see the U-shape. An exponential function can represent either growth or decay. If it starts out almost flat and then goes up in a smooth, increasingly steep curve, this represents exponential growth. If a curve starts out almost vertical and decreases in a smooth curve to an almost flat part extending to the right, then this represents exponential decay. Here is the graph of q of x as an example of exponential growth. When comparing the graphs of quadratic and exponential functions, the window you're viewing the graph in can play a key role. In the long run, when comparing a quadratic function and an exponential growth function, the exponential function will eventually surpass the quadratic function. Functions can be compared through tables of values as well. A table of values can be a lot like a window on a graph. The values used are important. Looking at the table of values provided for functions p and q, you can see how after an x value of 4, the exponential function grows quickly and the distance between the functions increases. Up until that point, the quadratic function p is greater than the exponential function q. Exponential and quadratic functions can be compared as equations, graphs, and tables, but each function has its own characteristics in form.